Good morning, everyone. Thank you all for coming here today. Let me introduce myself. My name is Moісеєв. I am a student of National Technical University of Ukraine, Igor Sikorsky, Kyiv Polytechnic Institute, Institute of Telecommunication Systems. Today I would like to talk about modulation. Do you know that both coding and modulation are main fundamental signal transformations in telecommunications? So every time you talk on the phone, take part in video meeting, use Wi-Fi or just listen radio, in your device signal always is encoded and modulated before transmitting and demodulated and decoded after receiving. I have divided my presentation into two parts. First of all, we will find out what is modulation and why it is needed for. And then we will speak about some kinds of analog and digital modulation methods. My presentation will take about 9 minutes. I can hand out a copy of the PowerPoint presentation if anybody needs it. And if you have any questions, you can ask them after presentation. So let's get started. First of all, I would like to talk about modulation and what it is. As you can see on this slide, modulation is the process of varying one or more properties of the carrier signal by the rule of signal called modulation signal or information signal that contains information to be transmitted. For example, the information signal could be an audio signal representing sound from a microphone, a video signal representing moving images from a video camera, or a digital signal representing a sequence of binary digits like a bit stream from a computer. The carrier signal is a periodic harmonic oscillation that has high frequency, so the carrier signal is significantly higher in frequency than the information signal. As you all know, the simplest harmonic oscillation has three parameters: amplitude, frequency, and initial phase. Thus, depending on parameter of the carrier signal is varying by the information signal, there are three main types of modulation: amplitude modulation, frequency modulation, and phase modulation. So, now we know what modulation is. Let's find out why it is needed for. As I mentioned earlier, the purpose of modulation is to impress the information signal into the carrier signal, which is used to carry the information to another location. After modulation, signal can be transmitted over the air or other medium. Also, as I mentioned earlier, information signal has low frequency. This fact makes information signal unsuitable for long-distance communication, because low-frequency signal very quickly attenuates. But this problem can be solved by transferring the spectrum of information signal to higher frequencies of the carrier signal. For example, if we recall the fairy tale of the brothers Grimm, Red Riding Hood, we will find that she put pie into the basket before across the forest. So, information signal is like the pie, carrier signal is like the basket, and modulation is like putting the pie into the basket. After that, she could easily cross the forest, or in our case, modulated signal could be transmitted. So, now we have clarified that modulation is needed for transferring the spectrum of the information signal to higher frequencies of the carrier signal. So, let's move on to the next point. In the second part of my presentation, I would like to talk about some kinds of analog and digital modulation methods. Analog modulation means that both information and carrier signal are continuous. But in digital modulation, an analog carrier signal is modulated by a discrete information signal. Digital modulation methods can be considered as digital to analog conversion. The analog modulation methods were the earliest types of modulation, and are used to transmit an audio signal representing sound in radio broadcasting. More recent systems use digital modulation methods, which impresses a digital information signal, consisting of a sequence of binary digits, on the analog carrier. As I pointed out in the first section, depending on parameter of the carrier signal is varying by the information signal, there are three main types of modulation: amplitude modulation, frequency modulation, and phase modulation. So, examples of analog modulation methods are amplitude modulation, AM, in which the amplitude of the carrier signal is varied by the information signal; frequency modulation, FM, in which the frequency of the carrier signal is varied by the information signal; and phase modulation, PM, in which the phase of the carrier signal is varied by the information signal. Examples of digital modulation methods are amplitude shift keying, ASK, in which carrier signal is periodically shifted between a finite number, that is power of 2, of amplitudes; frequency shift keying, FSK, in which carrier signal is periodically shifted between a finite number of frequencies that represent binary digits; and phase shift keying, PSK, in which carrier signal is periodically shifted between a finite number of initial phases. So now we are familiar with some kinds of analog and digital modulation methods. Well, this brings me to the end of my presentation. Before I stop, let me briefly summarize what I have said about main points. As you remember, I said at the beginning of my presentation that modulation is one of the fundamental signal transformations in telecommunications. Then we found out that modulation is the process of varying of one or more parameters of the carrier signal by the rule of information signal. After that, we clarified that modulation is needed for transferring the spectrum of low-frequency information signal to higher frequencies of the carrier signal. And lastly, we overviewed some kinds of analog and digital modulation methods. In conclusion, I would like to quote the well-known telecommunications expert Kevin Wilson, who said, "Modulation is the case when form and content of information are not opposed, but complement each other." So, this is the end of my presentation. Thank you all for your attention, and if you have any questions, I would be happy to answer them.